In this video, we'll learn how to use Excel to perform the hypothesis test for the mean when we know the population standard deviation sigma. And this is when we use the z-test. Z-test is a statistical test for the mean of a population. And we use this either when n is bigger than or equal to 30 or when the population is normally distributed and the population standard deviation sigma is given. Excel does not have a procedure unless we use the XLSStat or the MegaStat add-in to conduct a hypothesis test automatically for a single population mean. But we can apply the formulas manually to find the p-value. And if the p-value is less than alpha, which is the significant level, then we will reject the null hypothesis. Okay, let's take a look at the procedures. The first step is to find the test statistic. This is a z-test. So we need to find the z-test statistic. Z equal x bar is the sample mean minus mu naught. This is the population mean, and it is taken from the claim and used in the null hypothesis, H naught. Sigma is the population standard deviation because we do know the value of sigma. And then n is the sample size, the square root of n. To find the p-value, we are finding the area of the left tail, the right tail, or the two tails of the normal z distribution curve using the function norm.dist. This is a normal distribution, norm.dist. This function takes in four inputs: x, mean, standard deviation, and cumulative. X is the values of the test statistics on the z-axis. So this is the value of the test statistic, which is this one. Mean is 0 because this is a standard z distribution, and the standard deviation is 1 because this is the standard z distribution. For cumulative, the last argument, we put true if we want the area to the left of the x value of the test statistic, and false if we want that to return the probability density function at that location x. Okay, so for example, if I have this case is the left tail, so I have the negative z over here, and then this is the area under the curve. The p-value is just the area under the curve, and to find the area under the curve, we just simply input the norm.dist, normal distribution, and then I put in the negative z value, the value of the one that we are looking at, the test statistic, and then I put the mean 0, standard deviation is 1, and I put true because I'm looking for the left area. I'm looking for this area, so I want the cumulative to be true. It will give me the area to the left of that x value. In this case, it's minus z. For the right tail, under the curve, the area under the curve is your p-value. Well, for the right tail, we can still finding the area on the left side of the plus z, which is this one. And then we just take 1, which is everything, subtract the left area to give you the right area. Because I'm looking for the right tail, I'm looking for the area to the right, but there's not a direct formula to find that area to the right. The norm.dist always gives you the area on the left side of that x value. In this case, it's plus z, 0, 1, and 2. So it gives you the area on the left. So you take 1 minus that area on the left, the white one, will give you the pink area on the right, and that is the p-value that we need. For the two-tailed case, we just want to find one of them, and then we just multiply by 2 because they are symmetric, right? We just find one of the tails and we multiply by 2. And then the rule is if p-value is less than or equal to alpha, we reject the null hypothesis. And if p-value is greater than alpha, we do not reject the null hypothesis. Okay, let's consider this example. We want to test the hypothesis using the p-value methods. The null hypothesis saying that the mean is equal to A, and the alternative hypothesis says that the mean is not equal to A, it's different than A. And we are given the alpha level, the sample mean, x bar, the population standard deviations alpha, sigma 0.6, and the n value is equal to 32. Well, we know the sigma, so we know for sure this is the z test. So we need to compute the test statistic z, and applying the formula that I just showed you earlier, this formula, x bar minus the mu naught divided by sigma over the square root of n. We have x bar 8.2, we have mu naught. Mu naught, this one is just the claim value, the value that we assume to be true, and that is 8. And then sigma is 0.6, and then n is 32, the square root of that. It gives me 1.82. Now we look for the alternative hypothesis, and we see that this is a different notation, right? Not equal. So this is a two-tailed case. And we got the test statistic for z to be 1.89. We know the 0 is always in the center. So 1.89 is across to the right of that 0. And because this is two tails, there will be another minus 1.89 on the left side because they are symmetric. So the p-value is simply just the sum of this area and the sum of this area adding together. Or you just have to find the area of one of them and then double it or multiply by 2. So let's just find the area to the left of negative 1.89. So we can use a function num.dist, right? Num.dist. So if you type equal num.dist, you input the minus 1.89 because I'm looking for the area on the left side of minus 1.89. This is the standard normal curve, so the mean is 0, standard deviation is 1, and I type true because I want the cumulative, which is the area on the left. Okay, I hit enter. So this is my area on the left side. Now because I have two tails, I just multiply by 2, right? I take whatever the value I have here and then multiply by 2, and that is my final answer, 0.058758, right? You round it. And the p-value is 0.05, but alpha is only 0.05. So in this case, your p-value is bigger than alpha. We do not reject the null hypothesis. We only reject the null hypothesis if the p-value is less than or equal to alpha. So we do not reject the null hypothesis in this case.